First up, we have Manju from our product management team. He has a lot of titles. He has a lot of words in his title, like service provider, product management, analytics, location, but I will let him introduce himself.
All right. First of all, good afternoon and welcome. I think this is the first time I'm meeting most of you. I'm Manju Mahishi, responsible for product management for the analytics and location engine. This is going to be part of our what we call the public-facing enterprise solutions, and we're going to do a deeper dive today about our solutions, how we enable those newer applications that are emerging in this space. I'm also responsible for SDN and service provider initiatives, among other things too. So I want to just quickly give an introduction to where we are today in terms of our solutions for the public-facing enterprise, right? And what do we mean by public-facing enterprise, and what are some of the new solutions? We'll spend the next 1 hour going through that and giving you hopefully a good overview of what it is and how it is solving some of the use cases for our customers, right? So when we talk about the public-facing enterprise, it's a fairly broad market segment, right? It includes retail or wherever there is a large number of public Wi-Fi users in that venue, right? It could be a retail store, it could be a restaurant chain, it could be a restaurant, a hotel, a resort, where the question now increasingly is how can the venue owner monetize the network better? How can they engage with the customers better? It's not just about monetization per se, but it's also about engagement with the customer in that venue, right? How do they get more data of the demographics of the visitors in that venue so that they can improve their operations and better engage with their customers? So towards that end, we have a few very compelling solutions that work on top of our core Wi-Fi infrastructure. One is the Meridian application. This was an acquisition that we made about 6 to 8 months ago now. And this allows the venue owner to create a venue-specific application, if you will, and allow the customers to get information about the venue and allows the venue owner to better engage with the end user in terms of notifying them about any specials that are going on, anything that is relevant to that particular venue, so that the whole process becomes much more engaging, both from a customer perspective or the visitor perspective as well as the venue owner perspective. And to enable all of these applications for customer engagement and analytics, we introduced a new platform about 6 months ago called the Analytics and Location Engine, or ALE for short. And as we go through the day, I'm going to give you more information and also get some feedback. I'm also looking for some feedback from you as to what you see the utility of this, and hopefully you'll get much more information as we go through the day about this one. So Analytics and Location Engine, think of it as a platform, a middleware, if you will, that aggregates all of the contextual information from the Wi-Fi networks, right? When I talk about contextual information, it's about understanding who the user is, what device, what application, and it also has a location engine built into it. And all of this contextual information, if you will, is exposed through standard, very high-performance APIs that can be consumed by analytics and other applications. In fact, Meridian is also a consumer of this data, right? So think of it as, if I were to summarize what ALE is, it's a platform that can extract the business intelligence, if you will, from the Wi-Fi network and present that to northbound applications that venue owners and other enterprise customers can make use of the data to improve their operations and better engage with their customers, right? So we are trying to solve a large number of use cases that we believe are more and more relevant in this space, right? So there is one of the common use cases is finding out if there is somebody in the vicinity of a particular location, right? Presence. So for example, Starbucks may be interested to know how many people are within the Starbucks environment, for example, right? How many people are there, how many people are walking by. Any retailer would be interested in this kind of a knowledge, right? So or a mall, a large shopping mall, or a very large venue may have an application that allows the end customer to do wayfinding, right? Find their way around the large venue, right? So there are a spectrum of use cases that require location as one of the context, right? So they require the degree of location accuracy depends on, of course, the use cases. Of course, in a location like Starbucks or any small venue, the actual location itself doesn't matter as much as the presence information. But when you talk about a large venue, like an airport or a resort or any large shopping mall, this is where the location accuracy comes into play, right? So we are trying to solve a spectrum of use cases ranging from presence to so-called blue dot or indoor GPS type of applications, and also providing a way through the platform to be able to extract the contextual data from the Wi-Fi network and present that through to northbound applications. And as we go through the next few minutes, I'm going to talk more about the details of how ALE is structured, what kind of data we get, what is ALE by itself, and how it can be used to support all these northbound applications. And before we go to that, I would like to invite Keo, who is responsible for the Meridian platform, to go through the Meridian app platform, and he can walk you through how we can build an app and engage with the customers through the Meridian platform. Right.
Great, thank you, Manju. I don't think let's see here. No slides there, okay, great. Okay, so you guys probably, I think you just walked around and did like a scavenger hunty kind of thing where you got directions to a room, is that right? Did they do that? Mm-hmm. Okay, so that's sort of a very simple example of some of the things that we're working on and on the Meridian team. We were an independent company working on what we call engagement when you come to places. And when we originally started doing this work, we were calculating the device location ourselves on the handset. And this was back before the iPhone. And then with the iPhone introduction, we couldn't do it on the handset anymore. So we started looking at the network to determine the location of the device. And it turns out that there's lots and lots of interesting things you can do if you actually rely on the network to determine the device location. For example, if the network is responsible for tracking people, for one thing, you don't even need an application, right? There doesn't need to be an application on the device at all, and you can start to get generic analytic data about how many people are entering a space because the phone's probe and the network hears about it. But if you get your consumers, your users, your visitors to have an application, you can do a lot more because now you can get them to, for example, log into the application. And if they've logged in, now you have context as to who they are and also where they are. And then you start to getting information about how many times they might come to a location, and there's just lots of things. So if you can offer people services that are valuable to them and get them to opt in to receiving those services, having it done on the network layer means that you can, like Starbucks, you can, if I come there 10 times, maybe nothing happens. Maybe my phone doesn't throw me an advertisement or whatever. But if I show up that 11th time, they can then say, hey, you're a loyal customer. Here's a $1 off a latte or something like that. So we built a bunch of tools. How do I switch to I guess it's already, okay. Let's see here. Oh. So we built a bunch of tools that would allow you to create an experience. So I'll show you, for example. All right, so this is an example of a place that we deployed a while ago, and we built some tools that would allow it for them to very easily create their application. Right, so sort of drag and drop style application building. So we move that one to be the first one, and it'll sort of create the app. It's actually really complicated to manage the maps for these places. So we have these tools to allow them to drag and drop where things are within the location. So if I just zoom in here, you see all the things that are here, and you can again sort of drag and drop to create the content that you might want to show off at this location. And again, going back to how we're using the network for all of this, we can see the users on our map, right? So this is again coming off the network, and we're seeing all the people who are at the location in real time. Right, so this is showing us every single person. Every time they turn red like that, that's us basically getting an update. So these are all anonymous. We don't know who they are unless they have opted in and installed the application. And you're looking at me skeptically.
I'm the person in the group that doesn't install the apps, has the Bluetooth turned off, and
Tinfoil.
Yeah.
Like
That's me.
analytics
No.
at all in any
No, I
shape.
don't want
And
to
I
be.
think that's
I don't
fair.
want to be an analytic.
Well, she has a lot to hide.
That's fair, and that's where this stuff is. We have to be very careful about how we do this, right?
Can I ask a question then? Because for me, a phone sending out its MAC address or any device sending out its MAC address in a probe, I don't see that. I'm not that worried about that.
Yeah.
But what I see happening, and I'm absolutely sure it will happen if it hasn't already, companies will start to share this data, and suddenly you'll have agreed to one terms and conditions. And again, maybe that's not the vendor's role to dictate that, but you might agree to terms and conditions for one company, one retailer, and you're happy. And then and what's going to happen is that MAC address data is going to be shared over time between those companies, and it's maybe not something that vendors have to deal with. But is there anything that
So we have a
you
way
guys can
to
do
basically anonymize the MAC addresses. So on the AL, there's basically anonymized MAC addresses, and then they just are randomly generated, more or less, right? So there's that option. We actually are not in the business of collecting the data. We're a little bit different. There's a lot of companies out there that are actually making analytics products, and as part of their agreement with the end location, they say, well, we get to have this data, right? And we're not that way. And what we found amongst our customers is that they recognize that the data is very valuable, and they don't tend to want to share it with anyone else. But it is an open question, and it is actually an interesting question. It's fundamentally how wireless networks, right? You probe the network. Here's the MAC address. That's how you associate. That's how we put you through the captive portal and so on. So all that data is already in the network. It's
just what is done with it.
Yeah. And
There was the thing in London with the Wi-Fi enabled bins, and now they've pulled them out, or they've pulled the Wi-Fi out. I guess for maybe privacy. Well, obviously for privacy reasons.
Yeah, and so there's sort of doing that crosswalk that is, I think, where people get nervous, right? It's like knowing who that person is and then matching that to the MAC address,
right,
and connecting those two pieces.
There's been
of data
several
together.
cases of supposedly anonymized search engine.
Yeah.
Data. I remember AOL released some that was anonymized, and people were able to match up searches with people.
Yeah.
And again, maybe vendors aren't. It's not really their role, but probably the analytics companies themselves need some safeguards.
Yeah, and it's an interesting question. It's a very new, it's it's data that's always been there, but it's now places are looking to ways to. They have these IT budgets, and they're trying to stretch those dollars, right? And their marketing departments are very interested in this kind of thing. So their marketing, we have several customers where their marketing department is actually driving the infrastructure spend because their marketing department wants to have location data, and so they're basically paying for the IT. So it's sort of an interesting shift in how business is done, I think, in IT and as well. So, like I said, we have this data, and so we have lots of ways to take advantage of this that we're making available. And like I said, what's interesting about doing this on the network side is that if I want to opt in to a service like this, you can create an area, like I was saying, where you walk into an area, you walk into a zone, and then something happens on my phone, and you don't have to make it me that's getting the message. So we have, for example, we have some customers where they'll draw a circle around their cash register area, and when they get 5-10 people queuing in line, then they'll send a notification to backup tellers to come and work the lines, right? So it's sort of a funny, it's not, when you think about those kinds of scenarios, it's maybe not as creepy. And we have another customer it's a big like fair, and they looked at the data and found that there was a lot of people, kind of like what you're seeing right here. Over here you can see there's an event happening in this room. They found that there were a lot of people at the petting zoo area, more than they expected. And so the following year, they actually increased the size of that area. So it's sort of, they're using the data not just for, advertising to people, because I think that that's what a lot of people get excited about, but that's also one of the most dangerous things to sort of jump into. But they're using it to improve the overall experience of the venue. And there's a lot of things you can do with this information, and a lot of things that you can, a lot of ways that you can take advantage of it. And we're also working on, so Manju was saying, we have this network-based solution, which again, like I said, you don't need to be running the application. If you have the app, we can, wake it up when you're in a particular area. But it's a very unique capability when you do the location on the network instead of on the device. We recognize that there's lots and lots of different technologies out there. I mean, everything from light bulbs to Wi-Fi to magnets to determine location. So we're working actually on lots of different things. And I can show you an example here if I...
What's cloud-based services in terms of the apps, and then what's on-premise? Is the tracking and all that data hosted on a cloud server that then we have to worry about data privacy concerns, or what do I deploy locally?
Yeah, so locally you have the ALE, which is going to be your, it's tracking all the locations of everything, and at that point we have the cloud service, which is what you were just looking at just now. Originally we actually had everything on-prem, and the problem that we had with that was that people, like you walk into a location, and if you want to find your location, you would then have to basically tunnel into the network, and you would literally be on stuff deep within the network. And so customers didn't like that. So we set up a system where you could connect to the cloud and just be on 3G, 4G, and then it would just basically proxy the data.
And the solution be to put it in their DMZ? Is that what you're saying? They're guests, and then they've got to tunnel into the corporate network? Or
that was, yeah, exactly. So the network appliance was sitting inside of the network, not in the DMZ, and so you'd have to basically tunnel all the way into and which was a security concern. So we basically set up this second thing that was sitting out here, and then you could connect to that. And
so if you've got that cloud service where you log into it, do you have an option like some of the other vendor solutions out there do, where you can do a system-wide opt-out? Mm-hmm. So if you put in your MAC addresses, basically it's like the do not track on Safari browsing and stuff.
Yeah, we just have the anonymous solution.
Right, but even I mean, other vendors have anonymous solutions as well, but they at least give us the opportunity.
So you're talking about like a Euclid or somebody like that, who the analytics companies.
It starts with the C, pretty large company around here. Their option is that you can put your MAC address into the dashboard, and you will never be tracked on anybody's systems and show up in analytics. Anonymous or not, you won't ever be provided as a data point in that analytics. So
I would go to their website, and then they would send out an email to every one of their customers?
No, because you're saying that this is a cloud-hosted portion of it. Yeah. So if all the data is going up into here, and then I log into the server, the global server, to start the tracking aspect of it, because that person is opted out of the system because it's a cloud-based solution, I don't have to email anybody.
Yeah.
It's just anytime that it sees that and it's in an analytical report, it just deletes that data record.
Got it. I got it. Yeah, there we go. If,
am I not understanding
so there's sort of the two pieces to it. So the tracking is actually happening on your appliance.
On the ALE local.
Yeah, exactly, which is local, right? So we could add something so that you could say, anyone who's using Meridian in the world, we won't track them at the Meridian level, but it's still going to be tracked at the appliance level. Yeah, because that's just part of the network, right? That's like saying the network isn't going to respond to probe requests or whatever. I don't know if you have something.
Yeah, so just to add to that, on ALE we have this capability to anonymize the MAC addresses. Anything that is user identifiable, anything that can be personally identifiable, you can anonymize that, right? So all the MAC addresses and the IP addresses will be hashed. In the next on the two.
But you have to be able to decrypt that hash in some shape or form to match up. So if I come into the system and you anonymize me when I walk in, and you create that hash, you have to have a way to decrypt that hash to then update my records, reflecting that, I've moved from point A to point B.
So I think the use case for this anonymization is for somebody who can't track somebody at a personally identifiable level. I'm talking about a northbound application like analytics, where they only get to see a record, right? Okay. And they can't see the actual MAC address or the IP address. This is for the northbound application. On the flip side, though, just to add to what Kio said, some customers have asked for a whitelist of MAC addresses, right? So for some, they want everything anonymized except for some MAC addresses, right? Okay. So we are adding that capability in future releases, but for now, at a system level, we are just anonymizing. If you turn that bit on, everything gets anonymized. Right?
Okay, so this is the thing I was trying to show. So this is sort of some of the newer prototype-y stuff that we're doing with sort of high grain location. So if I move around, you'll see it basically tracking me more or less in real time and quite a bit more accurately than you might see with other solutions. And you can actually see what's happening here if I turn on this. So now what we're seeing is these are all of the different, can you guys see that? All the circles. So we're seeing it's putting me right here, and these are basically the access points that we're seeing and how we're able to get that kind of information. So if I wander around, obviously it'll basically track me as I wander through the space.
How real time is it? Like, what's the delay?
I mean, you can see
within
it.
A second or something?
Yeah, it's every second.
Oh, as quick as probes are being sent?
Yeah, basically, yeah. So you can sort of see it tracking me as I move around.
So that's going to depend on the probing behavior of the client, of course. So
yeah, and like I said, there's a bunch of different ways to do this. So right now, yeah, it's basically based on the probing behavior.
So what do you need anything on the client device to do this, or can you just base the networking, all the tracking?
It depends on how you're implementing the solution. So like I was saying, like with this.
It's a situation that for me pertains, because I work in disaster response. If in a disaster hit area, or we want to track people who have Wi-Fi switch on their smartphones, etc., but obviously they won't have any client software installed prior to that.
Yeah, and that's a perfect example of why something like the network-based approach is really valuable, because the network is actually, you don't have to have an application installed. The drawbacks of that are, you can't maybe engage with the person. Maybe the location accuracy isn't quite as good.
I mean, if you know 8 or even 7 out of the 10 blips you get on the screen is the person is trapped or on the rubble, and that you can actually locate them fairly exactly.
Yeah, that's exactly right. Yeah, and that's what you can use the network-based ALE is really great for those kinds of situations. Yeah.
I have a question on your demo. What kind of density of APs do you need to get that kind of accuracy? Obviously, this place is pretty hot, and you've seen the blips. You'd obviously have a lot going, but what's kind of the minimum you need from an AP density to get that kind of resolution?
So I'm going to cover some of the location requirements for location accuracy, but typically, we recommend anywhere from 1,500 to 2,500 square feet at a minimum, and that a device should be able to see at least 3 access points with good signal strength.
At what dB level?
Minus 65, minus 65 to 70.
AP needs to see the client at 65 or the reverse?
Reverse. So basically, at least if it's able to see it at that, we can work with more sparser coverage, but then it is going to impact the location calculation.
So basically, just voice grade Wi-Fi.
Voice grade Wi-Fi is what we recommend. That's exactly right.
1500, it's hotter than that.
Yeah.
Wow, that's a lot of AP.
So 1,500 to 2,500. So that's the range that we recommend, and again, depends on the end user environment.
The accuracy that you.
As I mentioned before, there's a spectrum of use cases that we are trying to target, right? Where in some use cases, the location accuracy requirement is they want it less than 5 meters or 15 feet or 10 feet. And then there are some where it is good enough to know if I'm in this room versus that part of the building, right? So in which case the accuracy doesn't really matter, and 1 or 2 APs for a mid-sized location would be fine, just for presence, just to detect the presence. So as I said, I'll come back and revisit this, but basically it depends on the requirement, the business requirement, and that defines how you want to lay out your Wi-Fi access points.
Associated to a specific SSID, or is it just you just being tracked just because you have your Wi-Fi on?
This is just me being tracked, yeah.
But if you don't not probing, how does it know where you are?
So
Your iPhone only probes periodically.
Yeah.
Yet that was tracking a lot faster.
Yeah. So it's sort of a hybrid of technologies that we're using, and there's actually ways to use like data frames and lots of other pieces of information besides just the probes.
So were you refreshing that when you were
No,
over
I'm not
there?
doing anything. It's just
No, I mean keeping it. How does it? If it's not associated to the same SSID, sending any data, there's no chatter coming from it. So there's no packets. How does it figure out where it is?
So it's this guy in this case is basically getting the information and sending it up to the network. That's how this is working right now. This demonstration. I am connected to Wi-Fi. Yeah.
Oh, so you're acting more like an active
tag.
Tag.
Yeah.
So you're listening, turning around and sending what I hear,
Yeah.
not the network telling you what it hears.
Well, yeah, exactly. So in this case, yeah. So this is a good point, and this is where that use case sort of grid comes in, right? So when you're looking at things like, for example, I want to know how many people are in this area, or I want to know how many people are like in the waiting queue area. Nothing has to happen on there, but if I want to know where I am very specifically, typically that's a different use case. That's me looking at a map or something like that. And so that's when we assume that you're actively engaged with
And you have
the
some
application.
app on the
Exactly. Okay. Yeah, so it sort of depends on the use case. And so we're actually looking at lots and lots of different
So
kinds of
for
technology.
Averts, the guys in the bottom of rubble,
Yeah.
it's the first, not this last.
Yeah. So if you're in the bottom of rubble, then probably you'll probe every. You could probe every. We've seen it happen every couple seconds, as far as every couple minutes. But if you're in the bottom of rubble, every couple minutes may be good enough. I hope so. But it depends on the overall question you're asking. What type of technology you end up deploying. So we have several kinds that we're looking at sort of jointly, and again, like I said, in that example, it's going to be probably probe based.
Can you interface with other Aeroscout or Ekahau tags to feed into your data set?
So we do have the ability now to integrate with Ekahau or Aeroscout as part of our AOS, the core AOS software. We have integrated with them. We do have several deployments, and especially in healthcare, mostly with both of these companies. Yeah.
And where is all the computational work done? Where's all the number crunching done? Is it on the AP, or is it on a network device, or?
The location itself, location calculation is on ALE, the analytics and location engine that I talked about. Yeah. So I'll give a little bit more color and details on ALE after it's done.
Because I was just thinking, like, if you could put that in a small, that the hardware in a small enough form factor, and you would stick that on a drone and you would fly it over a disaster hit area, and you can actually ping the devices and locate them that way. That would be a pretty interesting way to do it.
Have you had any use cases, like I know the big one that's been sold is to, I guess, monetize people, or however you want to phrase it, but the one that I always find useful for the customer, for me, I go into a huge store and it's a pain to find what I need. I go into a big, and particularly in the US, even worse, even bigger stores. But have you had customers doing that, retailers, where I've got an app and I want to find a tool in a big hardware store or whatever it is? Have you had that sort of thing done?
Yeah, I think he has a perfect example of that one.
That's that's basically where Meridian started.
Right.
It was actually in the American Museum of Natural History, and they wanted to know. I don't know how many people have been there, but it's a 500,000 square foot sort of configuration of, I think, 30 buildings built over 150 years, and they have little tiny corridors that look like they must be going to like a bathroom or something, and it turns out that you go down that and you're in a whole another section of the museum. very, very complicated space. And that was actually where we started, was that wayfinding piece. This one here, this is Macy's. So if I go to like stores and choose, let's see here. I think they have it in a couple of stores. Let me see. I'll put down.
Maybe the Powell's bookstore, maybe. Product finding.
Yeah, no, for instance, in Europe, in Ireland and the UK, one of the larger supermarket chains, Tesco's, they do install Wi-Fi, and you log in using your loyalty card number.
Right.
So they can basically see, based on your shopping behavior, from the information from checking out at the till, and where you walk in the store, they actually send you specific offers to get you to different parts of the store that you normally don't go to.
So you can, in this one, I don't know if you can see this, children's shoes. My location is not available, I guess. Okay, so like say take me there, and then it'll say from Candy, and then it'll give me the directions from Candy. So yeah, this one's Macy's, but yeah, Powell's Books in Portland. Hospitals actually are really big into this because hospitals tend to be very difficult to navigate. And there's also foreign language requirements, so offering navigation in whatever your native language is.
Right.
And doctors move around a lot. So like on Tuesday, Thursdays, they're in this building, and on Monday, Wednesday, Friday, they're on this building. So we have a bunch of customers who are hospitals, I think probably a dozen hospitals, and all that data is basically real time. So when I walk in the front door, I can be like, I need to go to whatever, pediatrics, and it'll...
And a hospital that's already set up for RTLS, doing traditional RTLS, would pretty much, in terms of AP quantity and placement, they'd be pretty much good to go. I assume they probably wouldn't need to be any changes there.
I mean, certain sections are good, other sections are not as good. Like New York Presbyterian has really great coverage in, I don't know, 80% of the place, and then the other 20% is kind of not as good.
Right.
And so it works really well in 80% and not as well in that 20%. But yeah, I think the finding products and that kind of stuff is pretty. That's a good use case as well. The things that I find really compelling are the things where you're taking data that you might not otherwise have. So it's kind of like the Google Maps. Google Maps will tell me how much traffic there are in different routes. And similarly, we can do that. So you can find, the shortest line for the bathroom, for example, in a stadium, or like the hospital example where they change every day, and so it just tells me where they are, and I don't have to keep track of their schedules.
You can see which is the best route to the other side of the store and bypass all of the people.
Yeah, exactly.
I guess that would just be if that was opened up to a customer.
Yeah.
If the store wanted that, they'd put the milk at the front.
Yeah, so there's lots of ways of utilizing, and so those are both great examples. And
quick question on that, and I know it's almost unanswerable, but I'll spit it out there anyways. One of the discussions that goes on, on Twitter and on different, like the higher ed wireless list, the use case of, okay, we get the concept of monetization of everything and trying to recover your cost, and then there's the very humanistic, altruistic, I want something like this just for handicap routing. I'm not going to make any money off of it.
Yeah.
Yet it still costs the same price. And it's kind of frustrating to some environments to look at this and say, oh my goodness, the things I could do with this to help people instead of make money off of them, yet the cost is the cost is the cost. And again, it's not your problem that people want to use it differently, but it ends up being kind of this, boy, wouldn't it be nice? And
yeah,
you know what I'm saying?
Yeah. I think so. Part of the difficulty is in order to have a sort of a minimum viable product, you have to have a certain, for example, density of wireless network. There are things, we've done things in the past where we just give you your starting location and then we don't track you, and that's actually quite useful because you don't have to have quite the same density, but you can still get your starting location, which is kind of the hardest part of it anyway. And then you can offer it for less money. It's one of the things that we're spending a lot of time on, is how to make this always easier to deploy. And it's a brand new product, right? So it's kind of like, when the very first PC came out, it was $10,000 or whatever, the home PC or whatever, and so it'll get cheaper, I think. But yeah, I mean, it's frustrating for me because it's still not as easy to deploy a location-based system as I want it to be.
Well, sure, and part of the problem is we're all so immersed in technology that we forget to be impressed.
Yeah.
Go right to what it doesn't do. And that's just what we've all kind of become, you know what I mean? Because it is very impressive, but you look right past that and say, well, it doesn't do this for me, so.
Yeah.
So kind of shame on us for, being of that mindset.
Yeah, that's pretty common, response. Yeah. Well,
6 months ago, you guys came highly recommended by Cisco, right?
Yeah.
And now, obviously not. We're actively looking for a wayfinding system, and you guys are on the top of our proof of concept list. And I'm curious now, with Aruba's purchase, how does that impact the customer with a Cisco infrastructure?
So we
$1 million question.
yeah. So
Is that what's going to cost him?
So we actually have a lot of customers who have Cisco infrastructure already, and our most, the most important thing to us is the customer. So we're still supporting Cisco. We've actually done a lot of work to make it such that they can't break it and hurt our customers. So yeah, I mean, we're still supporting it. I think that what you'll see is that, like to the earlier question, making it easier to deploy, making the accuracy improve, making the speed improve, all that kind of stuff. You're going to see that on Aruba first, right? Yeah, we have lots of customers who are Cisco customers. So I think similarly to Airwave or ClearPass, that are both agnostic, this will probably be the same. Yeah.
A question on your app. The one we did in the little scavenger hunt had the old version of Apple Maps where you had to go next, and follow yourself. Does it also have follow the blue dot and then actually talk to you, turn left?
Yeah, so that's coming, I should say. Yeah. So there's a couple things where if you have real-time location, you can do additional things. If you have really good location, you can do even more things. One of the first things we ever did, we actually implemented that, and it would automatically follow you and automatically jump to the next step. But that was a long time ago, and the accuracy wasn't as good, and so it would end up jumping you to the next step, which was when you weren't actually there, which was a bit disconcerting. So we have that's coming as we get the increased accuracy that we need.
Will it be possible to get the directions from your current location like you can with the cellular location? Because I was frustrated because I didn't start where we started, and then I couldn't pick up from someplace else because I wasn't starting at like the check-in desk.
Yeah. And if you go to a place where there is the blue dot stuff all set up and running, which we don't have right here right now,
location.
it actually will. Yeah, it'll actually default to your current location. So if you're at the Bellagio, for example, and you say, "Give me directions to the Martini bar," it'll just give you the directions, and you don't have to enter anything.
Figure out where you are.
Yeah, exactly. And like I was saying before, that's the figuring out where you are is actually the hardest part, more than the following the dot.
Yeah.
From a technical perspective, it's harder to do the dot following you, but from a user perspective, it's harder to figure out where you are initially. So we sort of have this hybrid solution that solves both problems, I guess.
Question, does it track in a three-dimensional plane? Because I mean, looking at that's two-dimensional. It's X and Y axis. Does it do height?
Yeah.
In the building, so you can see on what floor, for instance, somebody would be.
Yeah, it'll know. It can tell which floor you're on.
Yeah.
So it'll be able to. You can like this Macy's. This particular Macy's is, well, it's 10 stories tall.
I have to be honest, I've heard that before. How are you guys doing it? I mean, how are you determining that I'm not right below or above an access point that hears me louder? I mean, I know how some of the other systems work. I'm just curious on how yours does.
Dual can maybe answer that.
Let's say I'm on a second floor, and say I'm on a second floor, and how does that software know that I'm on a second floor and not the first or third?
Without, for instance, having access points in each floor.
Yes, so there are a couple of things there. I mean, in the algorithm, we have several sort of heuristics and floor disambiguation sort of algorithms that we have built to be able to disambiguate whether you are on a second floor or a first floor. It also depends a lot on the actual building also, like how strongly are you hearing the other floor's APs. So, it's an algorithmic exercise to disambiguate that. And it's not like 100%. It's not 100%.
No, but
it doesn't work, but 90%, 95% of the time it is
Even
able
if
to
your
distinguish.
strongest AP happens to be above or below you, I mean, it should be smart enough to know that, that one AP might be the case, but there's another 4 on that floor that are also strong, like if it was just based on that one.
So that's one of the heuristics, for example, and I'm sure you guys know that the problem kind of becomes even worse when you have open atriums.
Like in the malls.
Like in the malls, for example, right? So you are in the on the ground floor, but you might have an AP maybe at the 5th floor or the 4th floor, whatever is the ceiling height, and then you have other APs which are coming from the other floors into the atrium.
Yeah.
So that makes the problem much more
But
challenging.
say you had like a 3-story building and you have only APs on the ground floor and somebody's on the 2nd, 3rd floor, could it still?
No, if you don't have any APs on the other floors, then no, that wouldn't work. I mean, to be able to do location, you have to have APs on those floors.
Okay.
Yes. Yeah, you cannot sort of locate based on the bleed-through signal coming from the other floors. Yeah.
I realize it's probably the exception as opposed to the rule, but what about those folks that use directional antennas indoors? How does that impact? Like, I assume there's some sort of like a calibration system that has to happen prior to doing the application deployment?
Yeah, before.
Is that how you reconcile
directionality? I mean, there are sort of deployment guidelines that you have to follow if you desire a certain level of accuracy, and those are primarily dependent on your actual physical place, like what kind of place is it, like what kind of walls, what kind of ceilings, what kind of space, is it an open air space or is it a enterprise office kind of like a space like this, or any other kind of environment, right, a shopping mall or a hotel or whatever. So based on all those other characteristics, you would deploy the network. Right. So in the case of a directional antenna, for example, there might be some spaces where you would choose to use a directional antenna to either get a better coverage or maybe better location accuracy. So.
And are you recalibrating that for the app, or are you pulling that from the existing network system?
We pull that from the network because we know what kind of access points you have, and we know what
relying on, for example, airwave.
Exactly. Yes. Exactly.
Whatever.
Yes.
So ALE pulls the data from Airwave. All the access point placement and all the other information comes from Airwave.
Is there a manual calibration that needs to be performed to more finely tune?
Not today. I mean, that's one of the things that we have to work on, but not today.
Today, we are not doing any kind of post-calibration, post-deployment calibration at this point. But more and more, given the challenges of different environments, we'll have to do some tuning, right, to just make sure that we get the right level of accuracy. Like the floor flapping, for instance, that we have seen in malls, right? We have to tune some of the parameters just to make sure. So it's not 100% automatic per se at this point in time, right? We can probably get a confidence level of about 90 to 95% within a 10-meter range as to where you are, and 90 to 95% confidence on the floor level, right? But going forward, we'll be doing more calibration. We'll be inputting more calibration information into the location engine to further improve it. But today, we just assume that you deploy the network, it starts feeding data to ALE, and we compute based on available information. We do have a lot of heuristics that Dhaval mentioned, and we do take care of outliers. We have a lot of algorithmic tuning that's already in place. This is a matter of continuous optimizations as we move forward.
So I was going to say, I have a two-part question. Then one of them is from an infrastructure manufacturer support perspective, right? We've obviously talked about Cisco. We obviously know the Aruba platform.
Yep.
Who else's infrastructure do you work on, or are you quote unquote compatible with? And then I assume you're pulling that calibration data from the respective infrastructure manufacturers. Thing, right? In the Cisco world, it would be the MSE, and the Aruba world, it would be the ALE, right? So who all are you compatible with, and where are you pulling that data from? Does it require Airwave to calibrate ALE? I mean, how do those pieces work together, and what happens when those pieces aren't there?
Yeah, so just to give you a quick overview of how ALE is operationalized. So it pulls data. It needs Airwave to get all of the AP placement data from the visual RF module. So it gets that, and that's one of the inputs. And then today, we only support the Aruba infrastructure, right? Aruba controllers, Aruba instant access points. There is a proprietary protocol between the controllers and the ALE system. And so it's only talking, it's getting the data, and it's getting all of the, the context, it's getting it into a matrix, and then getting you the information about user, device, application, all the data frame, the data plane information, plus it has this location engine. To answer your question, today ALE is only going to support the the Aruba infrastructure, whether it's our controllers or our access points.
Yeah, and I guess I should clarify that Meridian is getting the information from
ALE.
Right, so ALE is doing the location calculation just like the MSC is doing the location calculation, and it sits sort of above that. So Meridian is actually not doing the calculation of location. That's being done by the network.
But whatever that, on the Cisco side, it'd be the MSC, on the Aruba side,
exactly.
it'd be ALE.
On the Meridian side, yeah, Meridian can consume data.
Yeah, but the ALE is basically Aruba's version, I guess, of...
It's Aruba's, think of it as MSC.
This is a
I guess
VM
the
or
question
an
was really
appliance.
targeted at Meridian.
It was, yeah.
So did you answer his, other than
so.
MSC and ALE, do you also talk to any other location engine?
So we have a open sort of API that you can send data to. The only two that we're currently accepting data from are ALE and MSC. But we've talked to everybody. But like I said, it's an open web API, cloud-based, so it could technically work.
So when you're doing your blue dot tracking, do you guys take speed and direction into account as well? Because I know, like Keith brought up on his podcast a few weeks ago, that as you're surveying an active survey, obviously you approach much quicker before you associate to an AP, and then you hang on much longer than you did on the approach. Do you take that kind of information into perspective as you're calculating?
Like a dead reckoning calculation.
Yeah.
So there's two pieces. So on the app side, on Meridian side, like I said, we don't really do the location calculation. We have, and I guess this answers also to the floor question. We have done things in the past where we add, we know all the paths. Like for example, we know how to get to the shoe department or whatever. So we can say there's no way that you could have gone from the 4th floor to the 1st floor without having gone through this path, or you have much worse problems. So you jumped or something. And so we can on that side. That's sort of all stuff that's not really. It's kind of stuff that we do little tweaks here and there. The location calculation is actually we don't. It's all there's no like walking or currently there's no like walking around and doing the like a fingerprint kind of thing.
Those points in time kind of.
So it's.
I think if I understood your question, you're kind of asking two different things. So one is from a calibration perspective is a different problem, right? If you're talking about the actual location calculation, then within ALE there are algorithms which kind of take into account the history of where you were, and your next location is sort of a weighted average move towards that. Like you can't really jump 100 meters in 1 second, for example, right? So that those kind of sort of algorithmic heuristics are sort of built in, which you can tune in a various different ways, like how much weight do you want to give to the prior one. So, kind of like distinguishing between a use case of somebody walking or running, right? Those two would be very different kind of problems.
Just to give you some follow-up example as to what are some of the things that we are thinking about. We all have used GPS, right? Do you guys know the accuracy of GPS, the actual commercial GPS?
It's down to about a meter, isn't it?
That's what we think, right? The actual accuracy is about 6 meters, right? So, but what we see on the application, right? I mean, what we see on a dashboard or on an application, we always see the blue dot, if you will, snap to the road, right? So the application is intelligent enough to snap you onto the specific path. That's what Dawal was alluding to as well. And these are some of the things, getting the path information from Meridian and incorporating that so that you don't get some funny outliers, if you will, right? Those are the things that we are evolving into moving forward.
Does the accuracy depend on the end user device?
No, I mean, so I'll talk a little bit more about how we are doing the location calibration. So today, we are dependent on probing from the device. To answer your question, the accuracy is not a factor, it's more about the latency, right? Because some devices may probe more often than other devices, right?